Here we're going to be taking a look at what makes triangles congruent. Starting out with the conditional statement that triangles are congruent if all their side lengths and corresponding angles are congruent. Now there's a couple ways that we can prove that something is congruent to another. One would be using a distance formula, and I'm not going to prove every single one of these distances, but we could use side, 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 and in order to prove side, 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 we would have to measure the angle or the distance from one point to another. So let's measure the point here, point A, which is located at -4, 1, to the distance here, which is at -1, 1. If I was to use the distance formula being from A to C, that distance would be equal to the square root of x sub 1 minus x sub 2 plus y sub 1 minus y sub 2. So all we have to do is substitute some values. I like to go ahead and line my stuff up, x1, x2, y1, y2. It's a little bit of housekeeping to make sure I don't mess up my variables. So let's count A as the first point. But when measuring distance, it doesn't actually matter which one you decide to be first. But this goes -4, 1. So -4, 1. And C is -1, 1. So -1, 1. Now all I have to do is substitute my distance, or my variables into my distance formula. So that I get -4 minus a -1, which now I have a +1 squared, plus 1 minus 1 squared. And I apparently forgot to put the squares in here. So now I'm going to go ahead and just simply calculate some values, and I'm going to be able to say -4 plus 1 is -3, and -3 squared is 9, plus 1 minus 1 is 0, so I'm left with the distance being the square root of 9. That means that my distance from A to C is 3. Now we know that the square root of 9 is plus or minus 3, but there is no negative distance, so we're going to go ahead and leave that as its positive distance, 3 units. That's how long that side is. Now if I was to take the measurement of each one of these, I would be able to go ahead and transcribe that into a new spot where I could have A prime and C prime. But there is another way to make sure that triangles are congruent to each other. Another method that we might use would be patty paper. So if we go with that lazy method where I'm going to trace A, B, and C, and so now this is my point B, and I could flip that over. And even though I'm not going to be oriented the same way, just by scratching that dirty side onto there, I see that this is my new B prime. So I get the congruent triangle through side, side, side in a lazy method. Lazy method being the patty paper. Very fast, not as accurate as taking the measurements myself. I could use a protractor to measure my angles, to try and do my angles, but just measuring the angles isn't going to prove that they're congruent. So what I know is that if all 3 of these sides are the same length as the 3 sides here, then they are congruent. Well, if they are all congruent, then the triangles are congruent. So we have a conditional when it comes to our proving statements, is we have a conditional which says if P then Q. We have a converse statement which is the reverse of this, says if Q then P. But we have another one. This is going to be called the biconditional. Now a biconditional is an if and only if. So if I was to try and visualize this, this says P happens, then Q happens. This one says Q happens, then P happens. A biconditional is P if and only if Q. So to see it as a picture, I have a P and a Q, but the arrow is going to go both ways. It means that both the conditional and the converse statements are true. Which leads us into another way that we might try to prove 2 figures are congruent. I could build them with a straight edge and compass. So I could put a straight edge down, and I could just simply take a measurement of one of these sides. So I could take the measurement of A to B. So now I'm off of that graph, and so here's my A to B distance. That means A to B. So what I'm doing is I'm constructing a triangle for myself based off of this current one. So we have a B. Now all I need to do is find my C distance. Well, from A, I take a measurement to C. And I'm going to do this in a lazy fashion, not like some of the other constructions. So I take just simply the radius measurement from A to C. But now I'm going to take the radius measurement from B to C, which is a little bit longer than that. And I'm going to place that point at B and create that arc. So I may not have my orientation exactly the same, but I do have now a congruent triangle where this is point C. And what I've done is I've managed to go ahead and recreate this, showing that they are congruent through their construction. And we do it in 3 different methods. So to show that their corresponding sides and angles are congruent is a simple way of proving that 2 triangles are congruent to each other. Remember, math rocks with a capital M.